They are employing logical architectures like data virtualization instead of physical ones to help fast-track the time to results, and hence the time to revenue.
Hello, selamat pagi, good morning, kumaha damang. How are you? Hope all of you is fine and keep spirit. Welcome to webinar Data Virtualization by Denodo. I'm Rahma from Cyber Standard Academy. It's an honor to be a moderator for today's webinar. I would like to thank you to Denodo. As brief, Denodo is a leader in data fabric in Forrester 2020. We also would like to thank to Maranatha Christian University for the collaboration to make happen this webinar and all participation for attending this webinar. Okay. First, don't forget, please follow and subscribe our social media Cyber Standard Academy for our update. And this is the Instagram, Facebook, LinkedIn, and YouTube. This is also live in our YouTube, Cyber Standard Academy. Okay. First, we will hear the opening speech from Mr. Lutfi Ardiansa as our Cyber Standard Academy. Please welcome Bapak Lutfi Ardiansa. Hello, Pak Lutfi, are you ready?
Hello. Halo, Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera untuk kita semua. Selamat pagi juga untuk Pak Teddy.
Pagi, Bang.
Beliau adalah dekan Universitas Maranatha. Lalu ada juga Mr. Alex. I would like to say hi. Hi, Alex. Oke. Selamat pagi juga untuk para dosen dan mahasiswa. Saya juga melihat ada beberapa rekan-rekan saya nih. Ada Pak Zano nih dari Unila ternyata ikut join. Terima kasih Pak waktunya. Oke, jadi pada pagi ini yang webinar kali ini kita bawa adalah Denodo sebagai salah satu data virtualisasi. Jadi seperti kita ketahui, data analisa menjadi hal penting semenjak industri 4.0. Lalu ditambah lagi dengan COVID. Jadi sebenarnya semua industri mencoba shifting menjadi 4.0 ready atau menjadi data driven business. Nah, sehingga menjadikan data menjadi faktor utama pengambil keputusan untuk bisnis dan ada juga yang bersifat menjadi suatu alat untuk menciptakan optimasi dalam bisnis. Nah, pada webinar kali ini kita memperkenalkan Denodo. Denodo is our partner. Denodo, pertama kita masuk ke dunia universitas, yaitu memang mengenalkan teknologi data virtualisasi ini ke mahasiswa dan dosen, yang diharapkan sehingga nantinya terjadi percepatan transformasi digital secara nasional di Indonesia. Nah, nanti Mr. Alex dan rekannya Mr. Siapa tadi? Tikic, ya, mereka akan menjelaskan. They will explain about what is Denodo, what is data virtualization, what is the use case, and also demo editing. Yeah. Jadi harapannya dalam webinar ini kita bisa mengerti bagaimana implementasinya data virtualisasi itu, dan mungkin juga bagaimana nanti dalam diskusi ya, bagaimana menggunakan data virtualisasi ini di universitas. Mungkin itu saja forward dari saya. Terima kasih untuk partisipasinya semua pihak. Semoga webinar kali ini bermanfaat untuk kita semua, dan semoga kita semua selalu diberikan kesehatan dan dijauhkan dari COVID dan penyakit-penyakit lain. Itu aja mungkin dari saya, Mbak Rahma.
Iya.
Baik, terima kasih Pak Lutfi. Thank you for your opening speech. Okay, next, please welcome to Mr. Teddy. Please welcome to Mr. Teddy Marcus Degara as a Dean IT Faculty University of Maranatha Christian from Bandung. Baik, untuk Pak Teddy, please. Halo
Ya.
Pak Teddy. Ya, kumaha damang
Terima
Pak.
kasih. Selamat pagi, Bu Rahma. Ya. Yang terhormat Pak Alex, ya, Mr. Alex Hall, Senior Director Partner Channel Sales and Business Development APAC, ya. Yang terhormat Mr. Katri Kayen, ya. Yang terhormat Pak Lutfi, yang terhormat Pak Irfan, juga pada pejabat struktural Fakultas Teknologi Informasi beserta rekan-rekan dosen dari Maranatha juga mahasiswa. Salam kenal semuanya. Ya, dalam beberapa tahun ini kita sudah masuk ke era industri 4 ya, Bapak Ibu ya, di mana otomasi dan pertukaran data ini menjadi tren ya di dalam dunia industri ini ya, mencakup cyber physical system, IoT, ya, cloud computing, and cognitive computation. Ya. Jadi kalau kita bicara mengenai komputerisasi ya dengan memanfaatkan layanan cloud ya, kita sering mendengar istilah virtualization atau virtualisasi ya. Salah satunya adalah virtualisasi data ya. Ya, apa sih yang ada di dalam virtualisasi gitu kan ya? Sebenarnya virtualisasi itu kita tahu ya, mengupayakan ya bentuk virtual dari sebuah fisik ya. Fisik itu apakah bisa berupa server atau berupa layanan, berupa sistem operasi gitu kan ya. Tentu ada banyak jenis virtualisasi ya yang akan kita bahas nanti di dalam webinar ini adalah virtualisasi data ya. Selain nanti sebenarnya ada virtualisasi perangkat keras, perangkat lunak gitu kan ya, memori gitu kan ya. Nah, walaupun istilah virtualisasi ini sebetulnya sudah cukup lama ya, dari tahun 1060-an, cuman waktu itu karena cloud computing belum booming tuh ya, nggak seperti sekarang gitu kan, internet dulu masih terbatas sekali gitu kan, jadi virtualisasi nggak begitu terkenal ya. Nah, sekarang sangat terkenal sekali ya. Virtualisasi ini memungkinkan bisnis kita bisa mengakses data internal kita, data eksternal kita ini dimanapun ya, dimanapun kita simpan itu kita bisa akses ya. Nah, ini yang menawarkan keuntungan, manfaat ini. Semoga nanti di webinar ini Bapak Ibu mendapat pencerahan gitu kan ya, bagaimana implementasinya di dalam dunia pendidikan ya. Nanti Pak Alex dan nanti beberapa teman-teman akan menyampaikan ini. Oke, saya nggak lama-lama untuk menyampaikan sambutan ini. Semoga melalui webinar ini kita dapat manfaat, kita dapat berkarya bagi masyarakat. Selamat mengikuti webinar ini. Ya, silakan Bu Rahma. Terima kasih.
Baik, terima kasih Pak Teddy. Thank you for your speech. Okay, please every participant before the material, we start the material. Please every participant open the video. We would like to take a picture first. hitungan ketiga ya. Oke, Mbak Mai and Mas Irfan, ready? Okay, thank you everybody. Okay, this is the time we will hear the explanation about data virtualization from Denodo. Denodo is the leader in data virtualization, providing agile, high-performance data integration and data abstraction across the broadcast range of enterprise, cloud, big data, and unstructured data sources and real-time data services at half the cost of traditional approaches. Okay, please welcome to Mr. Alex Hall as a Senior Director, Partner Channel, Sales and Business Development, Asia Pacific Denodo. Hello, Alex.
Hi, hello.
Hello, how are you in Singapore? Do you still work from home or you work from office, Alex?
We are still back home, as you can see from the background. We're still tucked away with masks and everything.
Okay, because in Jakarta and Bandung, most of us still school from home, work from home, Alex, of corona disease will be gone. Okay, I understand that you have some visual material that you have prepared as well, yeah, Alex. And
Yes.
the participants already curious about what is the data virtualization. Okay, if the presentation is ready, I will pass over to you now, Alex.
Yep.
And for the participation, if any question, we will give you a time to ask in QA session. There are 3 voucher training data analytic for the first questioner, Alex. Okay. Please, Alex, and thank you.
Okay. Well, I get a message that the host has disabled participant sharing the screen. So I think if somebody could help to fix that would be great. So while
Hello,
we're doing,
Alex.
yes.
Okay.
I cannot share my screen.
Okay.
The host has disabled participant from screen sharing.
Okay. Okay, maybe Mesaro, can you help the Alex?
Okay. So
co-host.
yeah.
Okay, just a minute.
Yeah. So I think while we're sorting out technology, so also first of all, thank you very much for having us here today. Good morning, Selamat pagi. Great to be here today. Thank you for joining us. And what we want to do today is really share with you the most modern form of data data integration. The ones of you who have a technical background, they're probably very familiar with tools like ETL, ELT, etc., which have been around for many, many years to integrate data. And the process has been working for a very long time very well. But with the upcoming of new data sources, of huge data volumes, of new data types emerging on a constant basis, this traditional way of ETL, ELT is coming to its limits of capability, capacity. We basically produce data faster than we can actually digest or ingest this data. And that's basically the background where we are coming from a data virtualization approach. And now my screen is also being shared. So I hope you guys can see it.
Okay, you are ready. Can I share the screen?
Okay, great. So today it's not only me. I also have a colleague with me, Kartik, who is from our solution engineering team. So he will cover some of the more technical topics. He will also show you a short demo of the product so you can get a little bit of a feeling. So, but let me first of all go a little bit into how does data virtualization actually come across. And I have here a picture, not from Denodo, but actually from Gartner, one of the leading analysts in the IT space. And you see here a timeline from the 1980s till now. How has data integration evolved? So what you see here on the left-hand side is actually, well, the good old days in the 1980s when I was young, and data integration was relatively easy because you had simple operational applications. But then when you wanted to bring this data from multiple applications together, you had something called a cube. So a cube is basically you extract your data from your data source, you aggregate it somehow, and then you expose it to your consuming application like a reporting tool. Technology advanced, the applications advanced, and the cube evolved into a data warehouse. But the concept basically stayed the same. You extract data from your application, you copy it to a staging area, you transform it and copy it over to a curated area, and afterwards you make another copy, transform it to a single source of truth, and then you make more copies and chop up the data, usually into data marts, which are then maybe solution specific or department specific copies of the data. So as I said, this has been working very well for many years. It's a proven technology. What changed in the 2000s was the upcoming of new data sources like IoT data, telematics data, sensor data, social media data, but also the operational applications produced so much more data suddenly. You had suddenly applications in the cloud which produce millions of clicks, data that can be captured, etc. So basically what happened was we produce new data types, huge volumes of data faster than ever before. One way to try to tackle this development was to introduce the data lake. And the ones of you who are familiar with technology, I mean, a data lake is basically a big pool where you can store data. Initially, it was also a very cheap and simple concept. These days, it's a bit more complicated. But what the data lake did not solve was really getting access of this data. It was basically, again, based on the same concept, making a copy of your original data, store it in a data lake. So you basically make, again, copies and copies and copies of data. That means effort, it's time consuming, it takes a lot of management time. Data lake itself has a few limitations, like, for example, incremental updates, like access control, etc. Again, you need to make copies. If you produce a lot of data, well, you need to copy it very fast. So this is basically the moment when customers reached out to Gartners and said, hey, isn't there a better way to get access to this data? And this is the moment when they came up with a concept of a logical data warehouse, what you see here in light blue on the right-hand side. And so what is a logical data warehouse? So here I've got a bigger picture of that. So here on the left-hand side, and this is a system architecture you see at a lot of customers, particularly large customers. You have a number of data sources. You typically have some ingestion process, ETL, ELT, whatever, and then you move your data into a data warehouse or into a data lake. You have some sandboxes, you have marts, you might have an ODS. So you have, this is what you see at the bottom is basically your storage infrastructure. At the top in dark blue, you see the different consuming applications. So these consuming applications can be reporting tools, industry standards like, for example, Qlik, Power BI, Cognos, etc. You have also a trend which is going to APIs to expose data, especially to operational applications like your call center, like your customer portal, your customer 360 portal, for example. And you have also applications like, I would call it the more modern data consumers like machine learning, AI, etc. So,
hello, Alex.
Yes. Yes, hello.
Hello, okay. Yeah, sorry.
Yeah,
Okay,
you
you
hear
can
me?
continue. Yes.
Okay, great. Okay, so if I have an environment like that, I mean, I can connect directly between my different data consumers and my data storage. The problem I have is that if I have my consumers here on the right-hand side and my data storage on the left-hand side, I very quickly get a picture like that because I need to make peer-to-peer connections from the data source to the data consumers. And as soon as I get more data consumers and more data sources, I get a pretty messy picture, which means it does not only look messy, but it's also hard to maintain. It's a lot of effort to keep all these individual peer-to-peer connections up to date. And if I make any changes in one of the data models of the consumer, I better make that in all the different consumers to assure that I have consistent reporting across different channels. So going back to this picture, to solve some of the problems that I just described, basically Gartner proposed, let's have here this layer called access layer or virtualization layer, which sits between your data sources and your data consumers. What this layer does is it really hides the complexity that you have down here to your data consumers. What these guys up here get to see is really just one big data source. So you don't need to know, is this a data warehouse? Is this a SQL database? Is this an SAP system? Is this a data lake? Is this streaming data, etc.? I can just go through that access layer. I access it with standard technologies or languages like SQL. And I don't worry about the technology and the complexity here at all. So that's basically the key approach for data virtualization compared to traditional data integration methods. And if you remember this picture here, once I put that data virtualization in place, you get here a very clean picture where you have your data sources here on the left-hand side. You have what we call a business semantic layer and a technical semantic layer in the middle. And then all the consuming applications like your reporting tools, your Excel actually, or your mobile application or your web will access just this one point. So making things much, much easier to consume this information. So let me go a little bit into more details. And this is basically, again, the same picture, just turned by 90 degrees. You have the data sources here at the bottom. You have the data consumers here on top, and you have the virtualization layer really sitting in the middle of it. So what it does is, first of all, data abstraction. And I mentioned that before. Basically, the guys up here, they don't need to know what technology sits down here. It can be an ERP system, it can be an SQL database, it can be a Hadoop, it can be in the cloud, it can be on-premise. So making it very easy to consume data. One of the key differences to traditional ETL, ELT physical data warehouses is that we do not copy data. And that's really the key difference in the, let's say, method that we're using compared to traditional integration methods. So I always keep saying, if you use classic data integration, you bring the ocean to the thirsty man. You have to move all this data to the thirsty person because you do not know what kind of data does he want to consume. So you have to bring everything to him. Data virtualization is different because we just, well, in this case, bring the glass of water to the sea, catch some water and bring it back. So we will only deliver the required data on demand as it is needed. And that's really the key difference you need to keep in mind when you talk about data virtualization. And why is that so important? Because what I mentioned earlier, if I make copies and copies and copies and copies of data, it's time consuming, it's slow, it's inflexible. If I just deliver the data as it is required, I can be much more agile, I can be much more flexible. You can maybe think of basically ordering a pizza. If I order a pizza today and the whole pizza shop has to come to my house, that's a lot of effort. If I just take Grab and they bring me the pizza, it's much more flexible and much faster. Okay, so keeping that concept in mind, one of the key differences is also that if I make copies of data, the data is always outdated. Depending on your extraction cycles, this can be, if you're lucky, a few minutes, if you're unlucky, 2 weeks. As we do not store data in the virtualization layer, we always go back to the data sources down here as required, which means we will always pull real-time or near real-time information. And this means better decisions for these guys up here because they use the latest information available. Okay, so let's go here to number 4, 5, and 6 on the right-hand side. Well, we do actually store some data in the virtualization layer, and that's metadata. So metadata is basically all this data about data, meaning it's, I understand what is my data source, I understand the data schema, I know the indexes, I know the primary and secondary keys, etc. So all of that is available over here. The other thing that happens is because whenever I want to access information from up here down there, I have to go through the virtualization layer, which means I get a perfect place for data security. And I think you can see that in all countries in the world, data is becoming more and more sensitive. There is more regulation about how can you use data, who can access data. And with data virtualization, you can do that in one centralized place. Traditionally, you have to do this down here in the individual databases. Now you can do that in one centralized place, which typically IT departments love. It's much more faster, it's much less effort compared to the traditional method. The same thing is about data extraction, because any data you pull has to go through the virtualization layer. You also get a full audit trail of which information was accessed. So that's important, particularly in environments where data is sensitive. Think of banks, think of government. They need to know who is accessing which information, and there's a lot of regulatory requirements now available that requires that. So virtualization from data virtualization basically covers that as well. So now with all that information you have metadata over here, you have a security concept, we can actually expose the metadata in a very safe way to the consumers up here. This means we can give to the consumers self-service capabilities. Traditionally, a lot of times, data consumers, an accountant, a data analyst has to go to the IT department and ask, dear IT department, can I please get this report, or where do I find this field? Now, with a data catalog that facilitates the data governance, the users can actually look at stuff themselves. So they don't have to go to the IT department. They don't have to wait maybe 2 days, 3 days to get feedback, but they can do it on the spot, which means their productivity goes significantly up. Yeah. So that's another key piece that data virtualization does. And then last but not least, a lot of companies are moving from on-premise to the cloud. Like, for example, also in Indonesia, I know Google has, for example, opened now a data center very recently, which will definitely help customers to move more and more data into the cloud as well. Data virtualization basically makes it transparent where data sits. This can be basically any form of a data source. This can be an SQL database. This can be a spreadsheet. This can be a Greenplum in the cloud. It doesn't really matter. We can bring all of this together for the consuming applications on top. They don't need to know where the data sits because they just access the virtualization layer, which makes it very easy for customers to move from on-premise into the cloud, for example, which goes then as a perfect tool for a data architecture modernization. Okay, so having talked about the concepts of data virtualization, let me go a little bit more into the details of how does the software actually work, and then I will pass it on to Kartik to dig a little bit deeper. What you see here on the right-hand side is again the same picture. Data sources at the bottom, data consumers on the top, and data virtualization here in the middle. So what we from Denodo can provide to our customers is this library of wrappers. So this is basically any kind of connectors to any data sources that exist. You see here all the different pictures of databases, data warehouses, Hadoop, ERP, big data, structured data, unstructured data. We have connectors for all of those ones and can connect. The other piece we can do is actually, we do not only read the data, if the data source allows us, we can also write the data back into the source. So what we then do is basically we can connect the different data sources. Then we can combine data from multiple data sources. And this is important. We usually talk about data from multiple data sources, not just from one data source. Big customers usually have dozens or hundreds of data sources that need to be brought together for better insights. And then this data can be exposed in different formats to your different applications up here. I talk about a few things here, but I will not go in too much detail because Kartik is going to cover that. One piece that is very important is the dynamic optimizer. Dynamic optimizer really means if I have here a lot of different data sources, I have multiple different ways of extracting that data. And as performance is always important, you want to find the best execution strategy to execute in a environment with multiple databases in the fastest possible way. And this is what this module does. And this is for our product actually one of the key differentiators because we have the best dynamic optimizer out in the market. The other piece that I want to mention is caching. So while I said earlier, oh, we do not store data here, as a pure teaching, we don't store data, but there might be situations where caching is actually required. It might, for example, be that a data source down here is currently out, it's up for maintenance, etc. But you want to still keep working. Then we could, for example, cache that data source while it's being down, and then it can be used any further for consumption. The security concept already mentioned. We can actually go down to a per user, per field level on the security side, which means it makes it very, very secure. We can do dynamic data masking that is required in a lot of banks and governments environment. So another key important feature. And then we have the data catalog that Kartik is going to show you. And then the data up here can be exposed through SQL language. It can be exposed, for example, through a REST API. So there's a multitude of different data sources or data types available, how different applications, and that can be basically anything from a reporting application to a mobile application to a partner portal, etc., that can consume the data from data virtualization. So with that quick overview, I want to pass it over now to my colleague Kartik, who will go a little bit into more details. So I will stop sharing my screen, and Kartik, would you like to continue from here?
Thank you. So with this slide. Hello, Alex?
Yes, we hear you.
Yeah, I can. Hi, Rama. I can share my screen. I'll do that.
You already closed host, Kartik.
Okay, I'm sharing my screen, and just let me know if you could see my screen.
Not yet.
Okay. Cool.
We can see you, Kartik. Can you open your video?
Yeah, sure.
Kartik, in India, right?
Yes, I'm.
Yes. Good evening, maybe, or good still morning, Kartik.
Yeah, I can now share my screen. So could you please confirm if you could see my screen?
Not yet, Kartik.
Not yet. Just did that. Yes, I got it. Yeah.
Okay.
It should be now, right? You should be able to see that.
Yes.
So first of all, thank you for this time, and very good morning and good afternoon to one and all. And my name is Kartik, and I'm based out of India, Chennai office. And I am the sales engineer for Denodo, like past 3+ years in the APAC region. And thanks, Alex, for this wonderful introduction about what data virtualization, who is Denodo, what we do actually. And now, with that said, I'm going to talk a little bit about the Denodo's technical capabilities in a live demo with a live demonstration. So for this demonstration, we have a scenario which is pretty much what we could see in many organizations nowadays, where they have the sources siloed across many different data sources, right? So for example, in this case, consider an organization, maybe ABC, having an Oracle as a data warehouse, which has some data about the overall organization as a piece of data, which is sitting in the Oracle. And nowadays, as you all are aware, that many organizations are looking for cost reduction, and they also want to acquire or procure some cheaper storage databases or some data lakes like Hadoop. So we have also have in the demo scenario, we also have a Hadoop cluster that is having an Impala engine running on top of Hadoop. And then as Alec mentioned, so many organizations also started moving to cloud, right? So basically, we also have one of the API which gives us the response as in a JSON, in the form of JSON, for us to read and combine with the other two data sources which I mentioned in the scenario, Oracle and Impala. So just to add here, Denodo is driven by a guiding principle called abstraction and decoupling, which means your consuming applications or your users, business users who are in need of data, should be abstracted from your underlying sources. They should be independent of where the data source is, how the data source is. It's all should be something abstracted from the business users. They should be just focusing how to read the data, how to do analytics on top of the data, and then improve their business. They should not be worrying about how the data and where the data is. So with that said, considering these three data sources, what we are typically going to do is connect to these sources from Denodo platform, bring in the data, whatever required for this combining Oracle, Impala, and Cloud API, and build a report which is requested by one of the business users. And also, please be informed that Denodo is a location agnostic. It doesn't matter where your data is, be it on-premise or be it in cloud. It has its specific out-of-the-box connectors to connect to your sources wherever it is. Moving on. So before I get into the tool, I just wanted to explain the report that with some more detail of what we are going to create. So basically, as I mentioned, my Impala source as a sales information, and my Cloud API contains marketing campaign information, and Oracle as my customer dimension information. So typically, we will connect to these sources from Denodo layer, join them based on common fields between these three, and then aggregate it by state to generate a revenue report based on the marketing campaign which happened very recently. So now I'll move to the tool for a live demonstration. This is the Denodo's development studio or design studio, you name it, and also an administration tool. So to use this tool, the minimum background that would be needed from your team or from any developer would be is to understanding of a SQL and basic knowledge or background about RDBMS. If he knows, or if he or she knows that, it's pretty easy that he can start picking up this tool and start creating models from connecting, combining, and then publishing the data. So he'll be able to easily or seamlessly do that if he has a background about SQL and RDBMS. What you see on the left side is the it's kind of an object tree, like how you could maybe if you all have used SQL Developer from Oracle or a Toad from Oracle, it lists down the databases, and under the databases there should be some kind of folders like something like this, and then each folder has its own information. In this case, the virtual model is something contains a model which I showed you in the example scenario slide, and I'm going to open that. So when I opened it,
Hello, Kartik.
yes,
The participant cannot see your tool user interface. Still, or
no, I'm not showing the Todd, Oracle Todd. I'm
Okay.
just telling that it is pretty much similar to the Toad or SQL developer. It's pretty much similar. The tool is with respect to UI, how it works, it's pretty much the same. Just to understand for the people, or maybe just to let them know the ease of use of the tool.
Okay. Okay, you can continue, Karthik. Thank you.
Yeah, no worries. Feel free to stop me whenever you have questions.
Okay.
Okay. So the report which I mentioned or showed in the example report, what we are going to do is something has been already created here. And when I opened it, you could see it pretty much looks like a field name, or like how you see it in a table in a RDBMS. It has field names, it has field types, and
Sorry,
it has
Karthik,
descriptions.
we can only see your presentation. We cannot see the user, the tool itself.
Oh, okay. So when I was sharing it, I was sharing for one screen, but it has, if I have to move it to another other tool, it should be against new share, right? Oh, I didn't know that.
I guess so, yes.
Yeah. I didn't know that. I'm sorry about that. Okay.
Probably need
So
to
usually in
stop
other
share. Yeah, now
other
we can see.
GoToMeeting webinars, we just alt tab move to different screens and it takes it by itself. So I'm sorry about that. I'm not very much used to
Now
the
we
Zoom.
can see your screen.
Okay, thank you, Alex. Thank you. So this is the tool which I was talking about, Denodo's Design Studio and Administration tool. And this is a virtual database, we call it, pretty much similar to a schema in the case of RDBMS. So under big data virtual database, I have different set of folders, and one of the folders we named it as virtual model. You can name it as it required for your organization or for your own use case. And this is the model which I spoke to you in the slide. And then when I just double clicked and opened it, and when I opened it, pretty much looks like a fields in a table with the type of its fields and the description, right? So I can execute this model. Just minimize this. Okay. Even when I clicked on the execution panel, this automatically pops up with a select star from a campaign evolution per country model, or a view you call it. So just automatically brings in this query, like how do you do a select of a table in an RDBMS? So right, just execute by clicking on this green play button here. So it's going to execute this model in a real time, ship the queries to the resources involved in this particular model, which I'm going to explain in a moment. So you see here, we executed a model coming from different sources and the data has come up. Let's see how this model is built. Basically, next to the execution panel, you see a option called tree view. I click on that and you should see a hierarchical tree structure, which will help you to understand how this model, like called campaign evolution per country, has been built in the virtualization layer. So basically, as I was explaining the scenario, we have three sources, right? So one is Impala, another one is Oracle, and the last one is the API from our cloud application. So basically, we brought in two tables from Impala. One is fact, another one is dimension, another one is an API which has marketing related information from a cloud application, and a customer dimension information from Oracle. As I mentioned, we did some joins, aggregation, and some transformation of fields to find the total sales. So in order to get the total sales, you need to use a function called sum. So that's all something we did it, and we finally built this report. This report, so when I executed, now you would be able to understand, okay, it's a query that consists of three different sources, four different tables or data from three different sources. We joined it in real time and then massaged it and then transformed some of the feeds, created new feeds, and then finally this report was built. So let me show you back the execution. Go to the execution here. So we saw the data here just by executing select star from campaign evolution per country. Now let's see how this execution is done through virtualization layer. Again, this is a tree which explains in detail about each node. Each node consists of each source. and it has details like start time, end time, response time. Start time is typically when the query is started, end time is when the query is completed. So when I click on each individual nodes, the bottom ones, this one is sending a query in a real time to Oracle, select fields from a customer table to Oracle, and this node sends a query to Impala. When I go back, just wanted to highlight here the key KPI of Denodo here. So query rewriting. When I go back to tree view, there were two tables from Impala, right? If you have any federation engine or any sort of other tools, what it would do is it will do a select star and store sales, select stars on the date dimension. There will be two connections sent to Impala, and then join of this will happen in the virtualization layer. With the help of Denodo's optimization, what happened is Denodo understand these two tables are from same source and have a join condition, have some aggregation like a group by, and also use some sum of function. So based on this evaluation of this particular query or metadata information, it has sent a query wrapped up with a join here between date dimension and store sales and a group by here, and also a sum of function here, if you could see it. Instead of sending two different queries, Denodo has sent a one single query joining two tables with some transformation. And these two tables are like 3 millions of data. By sending one single query, it has brought down the data by 1691 records instead of 3 million that has to travel from Impala to Denodo virtualization layer. So another source node is an API, which is accessed through a HTTP method, and that brings in around 300 records. And then finally it has been joined, and another join from this result set. And then finally this report data has been generated. Any questions? Okay. So now we have seen this model which is already being built. Let me show you how this model is being built from the scratch. For example, the first step in creating the model or a reporting view or a reporting model is connecting to your sources. So the first step is connecting to the sources. In Denodo, you can connect to your sources, clicking anywhere, right click new data source, and you have different connectors. You can see in the list here. So choosing the best connector is based on the source that you're connecting. In our case, it is Oracle Impala that provides JDBC drivers. So we can use JDBC and also ODBC for accessing MS Access or any kind of source that offers you a JDBC way of accessing that particular source. And also some multi-dimensional DBs like cubes, accessing cubes, and dimensions from DBs like SAP provided by SAP, Oracle Essbase. If you want to connect, you can use this particular connector. And if you have any web service application or any cloud application APIs that can give you back the response once you send the request, that could be in a form of XML or JSON, you can use this particular connectors. And file systems, still many organizations like banking still uses files, and they are putting some data or information into the file. Still organization needs that data also needs to be read and integrated with other sources for getting a meaningful information for their day-to-day business. So for those cases, you can use delimited file or Excel connectors. And Salesforce, which is a widely used CRM application in many organizations, we have a specific connectors and also custom. So if you have a data source that doesn't fit into any of these connectors, you can always create a custom data source, which is basically using a Java code. Also, we provide a Java development kit distribution along with our platform, using which you can create your own custom data sources for connecting to your sources that do not fall into these categories. Okay, so in our case, the first one is JDBC, that is Oracle and Impala. So basically, when you click on JDBC, it's going to show you a kind of a form where you have to fill in or key in the details of your data source to connect to it successfully. So just to save some time, so I'm going to open one that's already being created. I'm going to walk you through how this is being created. So I've given the name as Oracle TPCDC, and then the database here is basically Oracle 11G, which I have in my own system or a laptop. It's a version is 11G, but you have variety of connectors, starting from your Amazon's one, which is Athena, Redshift, and on some of the Azure databases like SQL and SQL Data Warehouse and Cassandra and DB2, different flavors and different versions, and Google's GCP's BigQuery and big data related databases like Hive, Impala, SQL Server, Microsoft SQL Server, and some of the other ones like MySQL and Oracle. We also have to do a different set of versions up to the latest one, which is 19C. And we have also a Snowflake, a cloud-based data warehouse, and many different variety of connectors are created as a database adapters, because this is very important when you create a source. We have to choose wisely, because this helps in Denodo's optimizer to rewrite the query, which I explained about rewriting two tables into one single query. That is all done based on the adapter that you choose here, because we understand the source better. That's why based on this choosing of this adapter, we understand the source better and then rewrite the query accordingly. If you choose a different one and we write it according to the ones which choose, and that could lead to something at the wrong one. So basically it is necessary to choose the wise adapter here when you create a data source. And once you selected, the driver class path is under the Denodo installation directory. And for Oracle, we distribute the JDBC drivers by default, and the class through which we want to access the data source. And this is very important again. Where is your data source? You need to give your host name or IP and the port at which it's running and the database. And then you can use different set of authentication mechanism to connect to your source, whatever it supports, like it uses plain username and password, Kerberos. It's on a single sign-on kind of a data source authentication, and pass-through session credentials. Based on the one which you want to use it, or it's been used in the underlying source, you can choose the one wisely here. And then key in the username and password. And when you click on test connection, it says JDBC connection tested successfully, and what is the version that you're using is 11G and with the bit information. Once you create the data source and test the connection successfully, you can move on the next tab, the create base view. That's where you have to bring in the necessary tables that is in your underlying Oracle schema. For example, in my case, it is in the EDW TPCDS, under which there is a tables, and under the tables, I have here customer, which is needed for our particular report generation. But you can choose any number of tables that you want to create it as a base view. Before that, the base view is just a replication of your underlying table. That's just a metadata information about your tables, name and its fields and its field types and its index, primary key, foreign key relationship. All these will be brought into Denodo Player. So when I click on create selector, it's going to bring in the particular fields from this particular table and its particular data types. It could be something different in the Oracle, but it matches with the Denodo's defined data types. It matches, but you don't have to worry about it. It's all done automatically because this is something we mark it as with our own data types, because today you're connecting with Oracle now, and again you're going to connect to Impala that has their different data types. But as a developer, you don't have to worry about, okay, I have to connect to Oracle and Impala that has two tables, each one with different data types. should I be worried how to convert those data types? You don't have to. So bring in the tables, we map the data types according to our standards, so that a developer, it is easy for him to easily combine the data table or a base view from different sources. So once you save it, you can name it and save it. And you can also execute like I did in the initial demonstration. So it just brings in the particular table's data. Similarly, I just did the same kind of steps for connecting to Hadoop engine, which is Impala. It is pretty much the same, and the adapter is alone changed, and some details about the class path and the class name and the information about where your Impala is running, on what port it is running, and the database. You can also do a similar test connection and move on to creating a base view, and then expand the schema that you want to use it to bring your tables from. And so far we connected to some of the traditional ones. Let me show you how we have connected to a JSON data source for our last data source, which is API based cloud application, which has information about marketing service, right? So just have to same like new data source and then JSON. You just have to key in here the information. I'm going to open the one here, SaaS space. Yes, here it is. And JSON API. And this is the data source which I was talking about. Pretty much the same, right? The form is for the new one and also ones you have already created. And just have to name it, and it's just basically sitting on cloud. HTTP client is the best way to access it. You can choose from many different varieties of data routes and configure it. Configuration window pops up, and this is where you have to give in more details about your cloud API to access it better and get it successful connection. Just have to use HTTP method post put. If say there are some APIs that will also request some post body responses to get the data properly, but in our case it is just get method, but you can use different varieties of HTTP methods. And then you also have some pagination option. If your API supports pagination and sends the data in a paginated way, then you can configure it. And if your API proxy or it runs on behind the proxy, also you can configure it. Authentication, that is something to authenticate Denodo by your cloud application. So you need to key in different sort of authentication methods, basic, digest, and most the widely used one now in the market is OAuth. It's kind of it's based on the JSON. It's based on the to key and which gets refreshed automatically. So OAuth is it's basically a different mechanism. And also another ones which is Spengio Kerberos and normal Spengio ones. But in my case, I'm just going to use admin access credentials, and I'm going to test the connection. The connection is successful, and once the connection is successful, you just have to save it. And on like how you saw it in the database connection, where it has create database tab here. Likewise, you could see it here for the other ones, other different connector, which is a semi-structured one like a JSON. You see it here. Click on create base view, and it asks for some tuple root, which is nothing but, for example, let's consider this example. So many cloud applications, if they are sending the response in an API way, there could be some hierarchical types or complex types, which is arrays or registers, or it could be like arrays of arrays or arrays of registers or registers of arrays. But in Denodo, we have an option, or it's also a key feature, which is a key differentiator from our other tools or other competitors, is that we can natively accommodate the complex structures, or we can flatten the complex structures. For example, if I just click on OK, just leave it to JSON root. I want the response from the root level. I'm just clicking OK. I see the response. It has the name, and under the elements, I have the fields about the marketing service. a marketing campaign information, which is under an array. So natively, we were able to support the array type in Denodo platform. But there is also another way where you can uncheck this option, provide the array name, which just that you want to connect to. For example, I'm just keying in elements here. And when I click OK again, it brings me just the array as a flattened structure. It's not under one single array. It is now flattened as its own type or own fields. This is basically the difference between the JSON tuple root option that we used two different ways. And there is also other option. Once, for example, you decided to bring it to support the native complex type, but after bringing in, you want to again flatten it. So in that case, you just have to, what you have to do is, you just have to save it here, and then right click in this particular view, which is now saved, new, and there is an option called flatten. So this flatten is something that will help you to flatten whatever we did it with the JSON wrapper pop-up window, which I showed you. So just right click, flatten array elements. So this will flatten the complete list of fields to the normal relational model. How it is, you could see it in any tables or any views. This is something very unique feature with respect to Denodo. Now we brought in all the views and all the data sources that are necessary to generate a report. So let me open the view, open the report again, and to combine these views, just you need to right click somewhere, anywhere here, basically, new, and there are different logical operations like join, union, minus, intersect, and flatten. So you can choose any of these for your particular business requirement or a report requirement. And then you can click on join. In our case, we're going to do the join. So it's going to show me a workspace where I can drag and drop the views. So likewise, we did it here already. And we brought in Oracle customer, store sales, date dimension, and marketing service API response. We just map the fields, drag and drop the fields for a common matching fields. For example, customer key from store sales to the Oracle customer key, and date key from date dimension to the Impala store sales date key, and then promotion key with the store sales promotion key. Once you map these fields, the join condition are automatically populated in the join condition tab. You can choose different joins in SQL, like how we have like different join types, like inner join, outer join, and left outer join, right outer join, full outer join. You can change it. By default, it chooses automatically inner join. And then as per the mapping of fields, we see that there are 3 mappings, 1, 2, and 3, and you have 3 different join conditions. Where condition, you can add a different filter where conditions after the join, what you want to apply after the join. So you can use from a drop down, choose the fields and key in the different operators and then values. But also there is an option of specify var expression in many organizations, where the var clauses could be very complex that needs some kind of doing it in manually. So you can write your own var classes here, which are something which is complex that you need to use it in this particular report layer. You can use this workspace to write your own logical logic of a var clause, which is complex in nature. And then a group by is something aggregation. So aggregation based on, so in this report, we are going to generate a sales or a revenue based on campaign or a promotion name. So that's the reason why we use in the group by clause, customer country, promotion name, and the month of the year. So it's going to aggregate the revenue based on these 3 dimensions. And next is the output tab, where you give final shape or look and feel to the business users so that they understand better this model. For example, it was customer country initially. You see it here, it's birth country, but we named it as country. Just you can rename it, something like this. You can key in here directly, promotion name. If you want, we can also change it, promotion name, for example. to make it a bit more clear to the business user who's going to access it. So yes, promotion name and then month. Instead of month of the year, MOI, we named it as month. And then this field is, so you could see here itself. So this field is from the view Oracle customer. This field is from a view marketing service, and month is from Impala date dimension. But this particular total field is from this particular report, which we call it as a virtual field, which we created on the fly. For example, you can click on new aggregator field here, and you should be able to see some of function being used on one of the field from your store sales, which has pricing details or paid information for each product. And Denodo by default has like 250 plus of functions available out of the box, which you can find it in the ELF function list. So it has all the different functions that you could see it in any RDBMS. But if you have any functions that is not available here, you can also create a custom function here with the JDK, like how I explained for the custom data source. You can use custom functions as well here in this list, and you can create a one and bring it here. So that's pretty easy if you are a Java developer. And then,
sorry, 10 minutes again.
sorry?
The time around 10 minutes is okay.
Yeah, sure. 10 minutes,
Okay.
I'll cover the rest. Yeah. I'm almost done.
Okay, thank you, Karthik.
Yeah, sure. And then I'm going to, so this is pretty much about how to create a model in Denodo layer. So from accessing 3 different or a variety of sources. For demo scenario, we have chosen 3, but in realistic scenario of any organization, 3 is not something, a number which any organization has. It's more than 3, it's more than 5, 6, 7. So just wanted to highlight this point here, just jumping directly into data catalog. So data catalog, as Alex mentioned, it's more focused on business users. So basically, it helps business users to directly log in from anywhere from their own desktop or a laptop. It doesn't require any kind of software installation. It works based on an URL, which Denodo admin can provide it to your business, any organization's business users. And then he can just log in using his own credentials here, username and password, and signing in would bring him a search engine box like a Google, inspired by Google, to be very honest. So this search box will allow a business user to search for the field name or a view name which he's looking for, to be used in a visualization tools like Power BI, Tableau, or reporting tools, you name it. For example, let's search for the view which we have seen now, campaign. Just typed in campaign and it brought me, okay, there are 2 views with the name campaign. So as a business user, I found that, okay, this is the view I was looking for. Let me see if I have the necessary fields inside that particular data model which I'm looking for. So when you click on that, it gives you another summary page with the details of the field names. And okay, I see that one of the field is what I'm looking for. Let me see if that gives me the data which I'm expecting. So in that case, you can go to the query tab, and graphically for a power users or business users, they are not very friendly with respect to SQL, writing SQL. So that's the reason why we have this graphical way of coding the models. Just you can drag and drop, and then you can run it. That's going to bring me the data. And once the data is it's been displayed here, you can also export it to a different formats, to HTML or Excel or a CSV or a Tableau dashboard. You want this data to be used for creating a visualization reports using Tableau. You can also use that to export it. And then next tab is relationship. So when you have a relationship between this view and any other view in the model, which I showed you in the tool, which I've created any associations, then it will graphically display the models here. And the lineage is the most important aspect for any business user who wants to understand which field is coming from which source. For example, if the total, I have not requested for a total field, where it is coming from. It is coming from a Impala source, which is from a table store saves, but this field seems to be a different field which is transformed using this particular field. And what is the transformation logic used, which is something you can see here. You could click it here and you can see the total field is the sum of function, which I showed you in the other two. You could see it here as well. So this will help the business user to understand this particular model and particular field, what it exactly as the data. And you can also do a database search. For example, if you click on this particular radio button, which talks about content-based search. For example, I'm looking for a name, customer name John. So, sorry. Yeah. So John. So what are the views that has customer name as John? So it is now based on real data based search, not the metadata based search, which we did earlier, like a campaign, which is a view name. Here it is John is a customer name, which is a data in these feeds, these tables, basically client and customers. And I have 5 more minutes. I just wanted to talk a bit about the performance. So basically, I just take for another 5 more minutes. So how does the execution works in Denodo? Because Denodo is basically a virtualization layer which connects to many different sources. Many concerns will be raised by many users or many people who's using the tool. How about the performance? So performance is key for any kind of solution that you go for when you have data siloed across many different sources. So what we do to reduce, or what is the scenario basically for the virtualization layer is DV doesn't store any data. It stores only metadata, the field names and field types and the view table names, and indexes, primary key and foreign key. So when we have only metadata, data is always external. So when we fire a query to the source, the data is coming and then we do the post-processing in the virtualization layer. So our main goal is to reduce the network traffic, minimize the number of rows coming from the underlying source by rewriting the query such a way your data source can process more the data in the data source itself and bring down the records only needed for post-processing in the virtualization layer. So data is always distributed in multiple systems. So our intention is here integrate many sources and post-process and send the data back to the consuming application. In that case, what we actually strive for is maximum push down the processing to the sources which are capable of doing it. In that case, for example, if you have files, that is not something can do the processing like sum of function or group by, that it cannot do that. Whereas your Oracle or Impala, it can do that. It has the capability of doing the processing group by and applying some functions and transformations. So now you understand what exactly the scenario for data virtualization. So what information that does Denodo have to execute the queries coming from your client applications? So incoming query, which could be a select star from where or group by coming from any Tableau or a dashboard reporting tools. So it's going to be a single query coming into the virtualization layer. And then what we do is we analyze the query, understand the sources involved. What are the key components of the sources? For example, primary, say a table from Oracle, is that defined with primary key, foreign key, indexes, or is there any virtual partitions done at the virtualization layer? And statistics, basically it talks about how many number of rows are in table and what is the average and minimum max values of each field, so that we can estimate a better cost and apply cost optimization techniques. And also we understand the source capability, which I mentioned earlier. So which is about who can process what. Are they really capable of doing the process? For example, I mentioned here, so RDBMS versus CSV. CSV is just a file, whereas RDBMS is capable of doing some processing. So I'll just close it with this particular example. So let's take an example here. Select a state field from customer an average of an amount coming from. So you can see my screen. I'm sorry.
Not yet, Karthik.
Oh my God. Yeah. So
Okay, it's already.
yes. So this is the example which I was talking about. Basically, we have a field from a customer and a sales amount from sales, and we are joining it, and we are doing an aggregation with a state from a customer. So let's see what happens with an example. So customer and sales are in two different sources. Let's see what is the best execution plan optimizer of Denodo comes up with. There are three options. One is naive strategy. So where your sales has 3 million and customer has 2 million, it has to do join. So it has to bring in 3 million from sales. If you go for any federation engine, it has to bring in 3 million, 2 million in the virtualization layer, do the post processing of joining and group by, and then bring the results of 50 records. It's going to take a lot of time because 300 million is huge, and doing a join on top of 300 million is another huge processing. It's going to take time. Let's talk about the future of optimization technique, aggregation pushdown. Based on the join condition and the relationship between exists between customer and sales, like a join condition with the primary key and foreign key, it sends a group by to the sales that brings down 300 millions to 2 million. And the number of records being processed at the virtualization layer is totally 2 million plus 2 million, 4 million. And it does an aggregation on top of it as we have a query coming in with group by C state. So this is something much more faster than the first option. And there is also another option, which is like a data movement, temporary data movement, where understanding the statistics like 300 million of a sales and 2 million of a customer, Denodo thinks that, okay, rather than bringing in 2 million plus 2 million, 4 million doing the processing of the virtualization layer, there is also another option, moving the 2 million of customer to the source where it is having a huge volume of data, and create on the fly a temporary table, move the 2 million from one of the source and create a temporary table, put the data there and do all the processing in the source where it has huge data, huge volume of data. So the only processing happens is movement of 2 million, and only records coming to the Denodo is 50 records. So if you do with these three options, the best one is second one, as it avoids the movement of data. And we compared and have some benchmarks with other federation engines. Denodo, this query takes 9 seconds. The data transferred is 2 million here, 2 million here, and applying aggregation pushdown, which is an optimization technique, we call it. Whereas the other federation engine, it takes 125 seconds or nearly like 2 minutes. And the data transferred is heavily huge, like 302 million, nothing. So it just brings in 300 and 2 million, just all in the virtualization or federation layer. So with this, I'm just going to hand it over to Rama. If you have any questions, you can ask me, or
Yes,
we can also have it at the end of the session.
Okay, you already finished, Karthik?
Yes, I'm done.
Okay. Okay, this is many question from the participant. There's Pak Agus from Maranatha University asks about what are the concept, strategies, and business model practical for data virtualization platform implementation in education learning processes, especially in university. What are the concepts, strategies, and business model? Because in the participant, most of them the academies from university, and they want to know what are the concepts, strategies, and business models for the virtualization platform implementation in education, especially in university.
Yeah. Okay. Let me, Alex here. Let me take that question.
Okay.
So, I mean, we work with university in multiple ways. I mean, we have on one side a lot of universities as customers themselves. For example, RMIT as a university in Australia is a customer of ours. Indiana University in the US is a customer we work with. Different use cases include typically the let's say, combination of maybe student registration and then execution of curriculum, marks, etc. That's a typical scenario where we see bringing together the different parts of the university together. So this is one side of universities using data virtualization. We have also some programs in place for working with universities in the sense of providing some classes and lecturing, etc., etc. So I'm not really sure where that question goes, but we can basically maybe discuss offline either of those afterwards.
Okay. Thank you for the explanation, Alex. These are from Pak Teddy Marcus. How to combine if we have no SQL data and SQL data?
Let me take that question. So,
okay, this is technical.
Yeah,
okay.
yes.
Okay, please.
So, to explain that, so once you bring the metadata to Denodo layer, it doesn't matter it is a NoSQL or a SQL. It's just about bringing the metadata and doing your modeling in the virtualization layer, like how I showed you in modeling of a combined evolution per country. It doesn't matter. So only when you execute the model, Denodo itself takes care of what is the query that needs to be sent to the NoSQL data source, what is the query that need to be sent to the SQL data source, and how it has to be combined. It doesn't really, you don't have to worry about it, which is implicitly taken care by Denodo. You just have to bring in whatever your sources are, just bring in the metadata information, do the modeling, logical modeling, just execute that model. You can go and see in the execution trace, based on the model built, what is the logic you use to build that model it's being sent to different data sources involved in that in their native format. For a NoSQL, it has to come up with a NoSQL kind of a query. For a SQL, it has to be sent with a SQL kind of a query. That is all taken care implicitly by Denodo's optimizer. You just have to execute that model.
Exactly. I mean, just to add to that, I mean, this is one of the key strengths of Denodo's data virtualization. I talked about the abstraction layer earlier. As an end user or as an administrator who's working on Denodo, you don't need to know MapReduce, you don't need to know Oracle SQL 12, you don't need to know Microsoft SQL, etc. You can actually work inside of Denodo. You can use mostly drag and drop capabilities, and then our connectors actually take care of the translation to those different languages. So this is exactly one of the big use cases to bring together multiple different technologies and make it transparent for the people who work with it. So that increases the productivity and also reduces the training effort for your colleagues.
Okay, Pak Teddy, any response or feedback? Pak Teddy, is enough for the answer?
Thank you.
Okay.
Yeah.
It's enough ya Pak Teddy.
Yeah.
Okay. Another question, Alex and Kartik from Pak Joni Setiawan. As far as I see, the main functionality is to restruct data only, because in data management, we need to modify data also. Is it possible?
Yes. Good question, by the way. So yes, you need to transform the data as per the business requirement, right? For example, in my example, which I showed you in the demonstration, where I have to create a new field, which is transformed on top of one of the field from the store sales, which is using a sum function. So as I also explained, there are like 250 plus of out of the box functions available that you can use to transfer or modify the data, like casting, type conversion from one field type to another field type. If you want to change the date format of the date fields, how you want to display the date formats. And for example, if you want to use some aggregation functions, average, all these are supported by out of the box. So which you can easily use it to modify the data that you want to expose it to your business users. So I think this answers my questions. Is questions, maybe if you want to ask more, maybe you can.
Oh, okay.
If
Thank
that
you,
doesn't
Karthik.
answer your question, yes.
Okay, Alex, any
No,
one or enough?
no comments from my end for a change.
Okay, thank you. There's another question from Pak Erwin. Do we still need ETL tools like Talent, Pentaho, and etc.? Because it seems very simple in Denodo. Is if we use Denodo, do we still need ETL tools like Talent, Pentaho, etc.?
Yeah, let me take this one. I mean, we are not replacing ETL. I mean, there are specific use cases where Denodo is, let's say, has unique features like, for example, the ability to create real-time data access, which ETL tools cannot do. Then there is a whole bunch of use cases which are overlapping, like, for example, building logical or building data models. You can do that in an ETL tool as well. This is then usually a decision of the project team itself to decide which tool gives more benefits. One of the big advantages that data virtualization offers, as Karthik also showed it to you, is how flexible and how fast you can be. I mean, we're talking here about 80%, 90% time savings compared to traditional ETL tools to transform and move the data. If you, just to stick with that, I mean, if you have a physical data warehouse, you probably need somewhere between 6 to 12 weeks to add a new data source. With Denodo, that's a matter of days that you can do that. So you get an incredible amount of flexibility. But then on the other side, you might have some scenarios where you have to move data from A to B. You migrate, for example, data from on-premise data source into the cloud. You still need to do that physical data movement at some time. And this is where you might need to, or where you want to use a specialized tool for data ETL, like Talent, like Informatica, etc. But you can then use Denodo, for example, to hide this movement of data as a layer on top. So you move your data underneath, but your consuming applications don't get to see that. So in summary, basically, we see quite a lot of projects where different tools, different technologies are actually combined. For example, if we're talking about a data lake project, we see Talent, we see Denodo as an access layer, and we see, for example, Cloudera as a data lake technology platform.
Oh, okay, thank you, Alex. I think the question, do you think the market in Indonesia is ready for the solution like data virtualization, Alex? Or do you have a use case in Indonesia?
Yes, absolutely. So I think that's a very great question. So, I mean, interesting enough, Denodo as a technology or data virtualization as a technology is actually 20 years old. We as a company have been doing this for 20 years now. Only in the last years, because of the change of data sources, data virtualization became much more popular and much more present. So in Indonesia, we do actually have already some customers. And that includes, for example, one of your very large conglomerates that are in Indonesia based. We have some semi-government organizations already. So I think the market is definitely ready for that. Why do I say that? Because we are not, you know, yes, we have a technology, but we're solving business problems. The business problems that customers have today is, I need quick access to my data. I live in a COVID-19 world where today there is a lockdown, tomorrow there is the lockdown is over, there is some business trend, and tomorrow, 3 days after, is a lockdown again. So you need to be very agile and flexible to react to those changing environments. And this is what Denodo can actually do much better than most other tools in the market. So based on that, I say Denodo is absolutely ready for the Indonesian, or the Indonesian market is absolutely ready for data virtualization from Denodo.
Okay, thank you, Alex, for the explanation. Maybe another new data centers like Google Cloud are emerging in Indonesia. And for your information, Cybertrain also partner in Google. Is your solution cloud is ready in also in Indonesia, Alex?
Yes, absolutely. I mean, first of all, the solution itself can be deployed on cloud, on premise. So there's absolute flexibility. We didn't have really the time to go through some use cases, but we have quite a lot of customers who are either migrating some of their data into a hybrid environment, so from on-premise to cloud, where Denodo is that access layer on top of that data movement. We have also customers who are going multi-cloud. So they're not only going for Google, but they have maybe some other data in AWS, some other data in Azure. Again, with Denodo, you can basically put a layer on top of all those different cloud environments, and then making it transparent for your end users. Where does this data actually sit? Plus, you also get a centralized access layer again. Again, you don't need to worry about where is my data on premise and cloud, etc. So yes, we're absolutely cloud ready.
Okay. Another question from us. How is the integration with Tableau? As we know, we also a partner in Tableau, Alex, and a lot of in Indonesia industry using Tableau technology. Is another integration with Tableau and Denodo?
Yeah, actually, I mean, let's say the approach of Denodo is openness. So meaning, I mean, we can connect to basically any kind of data consuming tools. We have, let's say, Tableau is actually one of our preferred technology partners. So we've been working with Tableau for many, many years. And actually in our demos, we only use Tableau to present the solution. Plus we have also a certified connector to Tableau, meaning if you install that connector and you use Tableau, Denodo just is a data source. So you just click on Denodo in your Tableau screen, and then all the different views are already available to you. So it's very, very easy to use.
Okay. Is it from a concern for data virtualization, Alex?
Sorry, could you repeat the question? I didn't understand it well.
Okay. Maybe our Pak Lutfi Ardiansyah have a comment or question for Denodo team for Alex. Halo Pak Lutfi.
Oke, mungkin saya mau kasih kesimpulan sedikit. I'm giving a brief summary ya. So, balik ke statement saya tadi di awal, data analytics menjadi suatu kebutuhan untuk saat ini, dan integration from data is actually being technical challenge. And using data virtualization, I think that homework is considered done. So as in business, yeah, we can more focus on analytics the data, create analysis on the customer behavior and taking business decision. Jadi, sorry, I comment with bahasa Alex.
No problem.
Jadi kan dalam mengambil keputusan mengenai data, sebenarnya data lah yang dia lakukan analisa. Jadi semoga dalam webinar ini kita bisa memutuskan atau mengambil suatu kesimpulan bahwa data analitik atau data virtualization di dalam data analitik ini bisa dibantu percepatannya menggunakan data virtualization dengan Denodo. Karena bisnis itu nantinya lebih dititik beratkan terhadap analisa datanya. Dan ya baik itu melalui misalkan pendekatan statistiknya atau visualisasinya, dan itulah adalah poin dari webinar kali ini. Jadi semoga tadi penjelasan tadi ya, melakukan integrasi dari beberapa database baik structure maupun unstructured bisa lebih mudah dan dipercepat menggunakan aplikasi atau platform dari Denodo ini. Dan tugas kita, para analis, para data scientist, untuk lebih fokus menganalisa data, bagaimana trennya, bagaimana proyeksinya, dan bagaimana keputusan bisnis itu diambil terkait data. Itu saja mungkin dari saya. Maybe from Alex, you can add where if this participant can download the Denodo or try Denodo, where they can have this software.
Yeah, actually, so we have multiple options available. So on our website, there is on one side a trial, which is a hosted environment where you can play around for about 2 hours. You have a use case scenario that you can follow. We also have on our website the option to download a product called Denodo Express. So that's a limited product, but I mean, it has full functionality, but for example, the results are limited by the number of rows. But this is a software solution you can always download, and you can use it for your own evaluation, playing around, trying out, etc., and it's free of charge.
What is the website? Alex?
I can give that. Maybe I'll type it in the chat.
Okay.
Yeah, I've already typed it in the chat.
Oh, okay. You're so fast.
Oh,
So
Denodo.com.
Exactly. I sell exile stuff, so I better have to be agile myself.
Okay, Alex, nice to talk with you about the Denodo data virtualization. We think this is the ending for the webinar. Do you have any other want to speak or conclusion or any Karthik or Alex?
Yeah. Yeah, maybe just a few last words. I mean, first of all, thank you for the audience. Thank you for the Data Academy team and the university to have us here for today. So I hope we were able to explain to you a little bit about, well, what is data virtualization? What can data virtualization actually do? I hope it became clear that data virtualization is the most modern form of data integration that is out there in the market. I mean, we're not replacing necessarily ETL or other tools, but we are giving people a different approach to data integration, which is, again, much more agile, much more flexible. And I mean, this is one of the key benefits that we can provide to customers. It's really that agility. Saving 80–90% of time compared to traditional data integration. It gives you the option to integrate basically any data, structured, unstructured, on cloud. And in addition to that, actually, it also gives customers cost savings. So we're talking here about 45% cost savings, which is particularly in a COVID world important as well. Plus, you also get a single platform for security, for governance, that is easy to use, what others cannot do. So, and again, it's, I think, a solution that is absolutely relevant for the Indonesian market. So I hope there will be a lot of questions that you will receive or that we will receive from the attendees today. And yeah, if there's more questions, please feel free to shoot.
A note from my side. So thank you once again for joining the session, and hope we were able to show this kind of a sneak peek about the tool. What I showed is something very kind of a sneak peek, but we have a lot to show. But given the time constraint, we were able to cover as much as possible. And once again, thanks, and hope you had a very great learning session.
Okay,
thanks,
thank you, Karthik and Alex, for your support, and also to Maranatha Christian University for the collaboration to happen this webinar. Okay, and any other
Yes. Hi, Mr. Alex. Maybe this is last questions. Okay. In Indonesia, many university. This is the very important. Maybe. Can you explain to us how much for price the Denodo? Is it any free for institution only, like university, school?
Yeah. So from a pricing perspective, we are charging our product actually by computer cores. So the core concept is basically including unlimited number of users. It includes unlimited data volumes. It includes unlimited number of data sources and data consumers. So it's really based on that core concept by itself. For pricing, I mean, if there are specific questions about the amounts, please feel free to come back to me. For universities, I mean, we have definitely special pricing options for universities available. Plus, I mean, we have also a free version that can be used, for example, for lecturing as well. So I think that's something maybe we can take offline after this call to explore what else can we do in that context.
Okay. So it's not free, like free trial for 1 year.
Well, as I said, Irfan, I think let's take this offline.
Okay.
And discuss because there are so many different uses.
Yes.
That we can look into. I mean, it's for lecturing, it's for internal usage, etc., etc. So I think it's better to understand that, and I think that conversation would be a little bit too intensive for the whole audience.
Okay. Yes, sir. Thank you so much.
Okay, thank you, Alex, Kartik, and Pak Teddy Marcus for the collaboration to make happen this webinar, and all participation for attending that webinar. For take a certificate, you can put your name in the link bit.ly/CCS Denodo Data Virtual. Okay. Okay, and any another question about Denodo or about the Cyber Data Academy, you can send the email training@dataacademy.co.id. Okay, see you all in another Cyber Data Academy event. Have a nice day.
Okay.
Good
Thank
evening.
you. Bye-bye.
Bye-bye.
Thank you. Bye-bye, everyone.
Thank you.
Thank you.